Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at work word problems. So work word problems are very similar to distance word problems or even unit word problems in that there's a mathematical relationship that you need to understand. And in this case, it is work is equal to rate times time. So the rate of work times the time worked. As an example, if we had someone that was an assembly line worker and they assembled 10 parts per hour, and we want to know how many parts would they assemble in a certain amount of time, like 3 hours, we would use our formula. Work is rate times time. So the work would be 10 parts per hour times a time of 3 hours. The hours cancel. And we get 30 parts. So we're going to use that mathematical relationship as well as a strategy that I'm going to point out in the next examples. In our first example, it says Lucy can assemble 4 parts per hour while Ethel can assemble 6 parts per hour. Working together, how long will it take to assemble 80 parts? This is a fairly straightforward word problem. We could just say, well, if Lucy's doing 4 parts per hour, and Ethel is 6 parts per hour, combined, they should be able to assemble 4 plus 6, which is 10 parts per hour. Then we could set it up, work is equal to rate times time. The work we want done is 80 parts. The combined rate is 10. We want to know T, and our answer will be 8 hours. So a fairly straightforward work problem. Unfortunately, not all work problems are going to be that straightforward. So I'm going to introduce a technique with this example because it's an easier example. I think you'll see the technique easier, and then we will use that technique on more difficult examples. So I'm going to suggest that we do this problem using a chart, similar to what we did with our distance problems. So our chart's going to be very similar. We will have rows for all of the people or objects or whatever are working. And then we'll have columns for rate, time, and work. We plug in what we know. We know the rate that Lucy works, 4 parts per hour. Ethel is 6. And we're finding time. So that's going to be our variable. So let T equal the time to assemble 80 parts together. And they're both working that amount of time. So we put that in for our time column. And then we're going to use our relationship, rate times time equals work. To complete the third column. So rate times time is 4T for Lucy. For Ethel, it's 6T. And that's the column that we're going to make our equation about. The third one that you complete, that should be the one that you use for your equation. So what do we know about the total work? Well, the work done by Lucy's work, which is 4T, plus the work done by Ethel, 6T, should equal total work, and the total work we want done is 80 parts. So the work done by each person, you add them up to get the total. Then we solve the equation, and this is the equation we started with when we did it the easier way. Divide by 10, and we can do a quick check to make sure that answer is correct. So we do a check. Lucy is 4 times 8, 4 times the number of hours. Her rate times her time is 32 parts altogether. Ethel is 6 parts per hour times 8 hours is 48 parts. Those two numbers add up to 80 parts. So we know we're correct. So we just answer the question. How long will it take? It will take 8 hours. Let's move on to a question where we're going to use this chart, but the rates are expressed a little bit differently than they were in this question. In our next example, a roofer can shingle a roof in 4 hours. Her helper can shingle the same roof in 6 hours. How long would it take to shingle a roof if they work together? So in this example, it's not how much work is done per hour, it's one job being done in so many hours. So for the roofer, it is one roof per 4 hours. So that rate would actually be 1/4 of a roof per hour. Okay, so you have to remember it's not a rate of 4 roofs per hour, it's one roof or one job in a certain number of hours. So then this would be the rate. So we're going to get into fractions. So the roofer would work at a rate of 1/4 of a roof per hour. Similarly, the helper's rate would be one roof in 6 hours. So 1/6 of the roof per hour. That would be that rate. The question asks how long, so time, that's going to be our variable. So our unknown T is the time to shingle the roof together. Both the roofer and the helper work for T hours. And according to our relationship, work equals rate times time, we know the amount of work that each one does will be the product of their rate and time. So this would be 1/4 times T, which I can write as T over 4. That's like a T over 1. This is 1/6 times T, which we can write as T over 6. Now we know the amount of work done by the roofer. We don't know the amount of work done by the helper. And those two amounts will add up to the total amount of work done, which in this case is one roof getting shingled. So that's our equation. T over 4 plus T over 6 equals 1. So the work done by the roofer plus the work done by the helper equals one job done. Now we can solve this. This is a fractional equation. We learned to solve fractional equations by multiplying by our lowest common denominator. Our lowest common denominator is 12. So we're going to multiply both sides of the equation by 12. And when we multiply this side, we multiply every term. So that's like 12 over 1 times T over 4. And don't forget to multiply the other side by 12. I see that mistake quite often. 4 goes into there once, there 3, so I have 3T plus into the 6 goes into there once, into there 2. That's 2T is equal to 12. So 5T is equal to 12, and T is equal to 12 over 5, which is 2.4 hours. Now, when you're doing these, use some logic in when you get a result and say, does that sound right? Like if alone the roofer can do it in 4 hours and alone the helper can do it in 6 hours, we know that it's going to be less than both of those numbers. So just kind of think about what would be a reasonable amount. When we do a check, we find that the roofer's amount of work done is the rate times the time. So 1/4 times 2.4, which is 0.6 of the roof. The helper rate times the time is 0.4. Those two amounts add up to one roof being completed, so we know it's correct. Have we answered the question? Yes, we have. How long does it take? So we make a statement. Our statement, it would take 2.4 hours to shingle the roof together. I would recommend that you do problems that are similar to our second example before taking a look at this example. It throws another little twist in there, which is often what happens with word problems. But I'm going to stick to the same format, and whatever the twists are, this format should be able to handle it. So in this case, we have a question that says, Ricky can clean a house in 5 hours. If Fred helps him, it takes 3 hours. How long would it take Fred to clean the house by himself? So instead of knowing how long it takes the two individuals and asking how long together, we know one individual and together. So let's put in what we know. We know Ricky's rate, one house in 5 hours. So that's 1 over 5. 1/5 of a house per hour. We know the time of them working together is 3 hours. So this is our time when they work together. We're always, when we're doing these questions, is when our chart should represent the time working together, not individually. And they're both going to be working together for 3 hours. What we don't know is Fred's rate. So we could let R be his rate if you want, and then we can solve that. But remember, when you get the rate, it doesn't tell us how long it takes. You could let your variable be how long it takes Fred alone. Because I typically like to make my variable represent what the question asks, I'm not going to let R be my variable, the rate be my variable. I'm going to let time for Fred to clean the house by himself be the unknown, and then when I get an answer, I've answered the problem. So T represents the time for Fred to clean the house alone. I don't put T in here, that's not the rate. If it takes T hours to clean one house, the rate will be one house in T hours, which will be a rate of 1/T house per hour. I know it's confusing. You have to understand the relationship between the time and the rate. So Fred's rate is going to be 1/T. Now I can express the work that both of them have done. So it's just rate times time. So Ricky will do 1/5 times 3, which is 3/5. Fred will be 1/T times 3, which will be 3/T. And then we can set up our equation about the amount of work each of them has done. So the amount or the portion of the house cleaned by Ricky will be 3/5, plus the amount or portion of the house cleaned by Fred, which will be 3/T, will equal one house being cleaned. Again, we have a fractional equation. We multiply both sides of the equation by our lowest common denominator, which is 5T. And when I multiply both sides of the equation, that means every term on both sides. 5 will cancel, I'll be left with 3T. T will cancel and I'll have 15 equals 5T. Subtract 3T from both sides and T will equal 15/2. As a decimal, that would be 7.5 hours. When we do a check, we already know that Ricky has completed 3/5 of the house, or 0.6. Fred will have completed 3 over his time alone, which is 7.5. 3 over 7.5 is 0.4. We can see that these add up to one house being cleaned. So we know that our answer is correct. Have we answered the question? Yes. Because I let my variable equal the time rather than the rate, now when I'm done, I've got my answer. So we write our statement. Fred would take 7.5 hours to clean the house alone. I know that these word problems are challenging because we're working with times and rates, and we're also working with all sorts of variations that get thrown in on the problem. The approach that I've shown you is not the only way that you can solve them, but from the many years I have had teaching students who had to complete these types of problems, I found the most successful students were the ones who did do the chart. They got their information organized and they had sort of a foundation then to build their equation. So I recommend it, but if you have shortcuts or other techniques that you find work for you, then do those. Everybody has a different learning style, everybody has a different approach, and there's nothing wrong with that. But if you're really lost, this might give you something to start building your foundation. The best thing to do is to try to find very similar questions to the ones that I've done, and then start looking at ones that have more variations than what I have shown. Take care, and we'll see you on the next video.